We're going to solve this trig equation that says sine x over 2 plus the square root of 2 equals minus sine x over 2. We're going to solve for a value of x such that it makes this equation true. Now notice it doesn't give us any specific interval over which to work, so we're going to find all possible values. Now there's an infinite number of them, but there's a way to describe the infinite number of them very carefully. First, in order to do this, we have to solve for all the x values in one rotation of the unit circle, and then we can work on expanding it from there. So first of all, I'm going to put all the terms that have the sign on one side and all the terms that don't have sign on the other. So in this case, I'm going to add sine x over 2 to both sides. That gives me 2 sine x over 2 over here, plus the square root of 2 equals 0. Subtract the square root of 2 from both sides. 2 sine x over 2 is equal to minus square root of 2, and then divide by 2. Always isolate the sine or trig function term first, then take a look at it. Now notice this number over here is a standard number that you can see on any unit circle. So moving forward, when I look at this, I know the period of this function here on the left is not the normal 2 pi. What I'm going to do is let x over 2 equal theta and then work from there and come back to this later. So I know sine of theta equals minus square root of 2 over 2. And I think about, okay, where on the unit circle, what angles does sine of that angle equal minus square root of 2 over 2? Well, that for sine, it's negative down here in the 3 and 4th quadrants. So it's always where we got a reference angle 45 degrees. So that means that theta is, let's see, this is pi over 4, 2, 3, 4, 5 pi over 4, 6, 7 pi over 4. So right now we have two solutions. Theta equals 5 pi over 4. I think it's a 4, not a 6. 5 pi over 4. And theta equals 7 pi over 4. Now, that is the two numbers that will solve this equation within the first rotation. Now, if I want to keep thinking about doing the rest of the rotation, so in other words, if I want another solution here, and I can just rotate one more time and I'm back at another solution. Rotate another time, back at a solution. So every time I rotate 2 pi from the point at which I had a solution previously, I come back to a second or third or fourth solution. So that means if I add 2 pi, or multiples of 2 pi, to each one of these, I will get all the rest of the solutions. Where in this case, k is an integer. Don't forget to write that. It's important to know that k is an integer and not a real number. Now, most of you are screaming, oh, but we don't want theta, we want x. Okay, well, I know that theta is x over 2. So I'm going to say x over 2 is equal to 5 pi over 4 plus 2 pi k. Then I'm going to say that x over 2 is equal to 7 pi over 4 plus 2 pi k. Now in each of these, if I want to solve for x, I just multiply everything by 2. So I have x equals 10 pi over 4 plus 4 pi k. X is equal to 14 pi over 4 plus 4 pi k. Now I can see that these first terms in both are not simplified. Let me scoot this out just a little bit. So simplifying, I get 5 pi over 2 plus 4 pi k. And then over here I get x equals 7 pi over 2 plus 4 pi k. Where k is what kind of number? Everybody say it together. K is an integer. Again, don't forget to write that. And now there's our original equation solved for all possible values of x.